While graphics processors, or GPUs, are certainly well known in the world of gaming, the question of whether they can be used as accelerators in high-performance computing for supercomputers remains to be seen.
Fundamentally, the supercomputing community is a community that always looks ahead on architectures. And one of the challenges that they really see is, even with heterogeneous computing, the CPU is still consuming too much power.
Today's CPUs, which are really latency-oriented machines, you're running at high frequency, you're trying to execute your instructions as fast as possible. And the shift to throughput processing, which is really what GPUs in some sense are about, is an absolute necessity and is the trend going forward.
Accelerator technology already has taken off. So 20 out of the top 25 supercomputers today use GPU technology. We're working very closely with Intel on the Intel mic technology, so that's not exactly like a GPU, but it's similar accelerator technology that has very different performance per watt types of characteristics.
Our belief is that in order to use acceleration for parts of workloads or parts of applications or certain types of applications, you really do not have to take a very expensive detour. Forget everything you've learned or what you have developed before versus simply be able to extend it.
To do it best, it takes a device that was optimized for what we're after, which is data parallel programming. So it should be highly programmable and it should be high performance, but it should also have a very high performance per watt. And that's what our mic architecture is about.
First of all, I think Intel is telling the world that heterogeneous computing is the path forward. That's number one. That's the most important thing. Intel is now telling everyone that Xeon is not good enough, CPUs aren't good enough. So we agree. We totally agree with Intel. We obviously have had a product for 4 years in the market, and in very high volume shipments, we power 3 of the top 5 supercomputers.
The one drawback of GPUs is that they're very hard to program. And traditionally, they've needed many man-months or man-years to move an application over to a GPU. But with announcements like the one made today for OpenACC that involved a group of hardware and software vendors, Cray, PGI, which is here at the show, NVIDIA, which is a manufacturer of processors, and the CAPS, a software company from Europe, that consortia is trying to make it possible to program these GPUs very simply and more efficiently. And if it can do that, if we can do that, then really the promise of technologies like GPUs can come to pass.
To move your code onto these GPU systems, there's some human effort that's required. Now, right now, that human effort is to take your code and rework parts of it.
You have to program the device itself, and this is where we have a huge advantage. It's an x86 device. You can do anything on it programming-wise that you can do on any of our processors. It's just an x86 device.
A GPU requires a very special programming model to use. But an x86 is just, hey, here's my code, it's C code, I can run it on anything. They use something called OpenMP to parallelize the code. They use a distributed message passing interface called MPI. All these things are very hard for accelerators like GPUs to do, but we can do these as well. So I think Intel Mike's sort of their pitch was, hey, it's the same software that runs on Intel, you can run it on this accelerator that they have.
The primary way that we encourage people to use accelerators is an open standard called OpenACC, which is actually a directive-based standard. Most of our competitors actually don't conform to this open standard. NVIDIA is the only accelerator that conforms to this open standard.
NVIDIA has invested 5 years now in their CUDA development, and today they just announced the NVIDIA directives, which makes it much simpler in a standardized way to get your code running by inserting a very simple directive in your code. Basically tells it, go off and figure out how to work with this GPU. So that's where we see all of the momentum today, because they've invested in this software ecosystem. So I would say today, as far as what we're shipping, clearly NVIDIA is in the lead. AMD, with their fusion architecture, that holds a lot of promise. So we're certainly working closely with NVIDIA and watching that technology. In Intel, And when you're as big as Intel and you put your mind on investing on something, mic is going to be very interesting technology, though that's really only in a sort of software development kit type of system now. It'll really be the end of 2012 before we see the first large supercomputers being built out of the Intel mic technology, and we'll be right there with Intel when that happens.
From our perspective, we want to provide access, from Mathware's perspective, we want to provide access to as many technologies as our users have. So we are in a wait-and-see mode with other technologies to see how they evolve. The good news about NVIDIA and their GPUs is that they have a very large ecosystem of libraries that allow us to provide first-class support for our users that need math algorithms to be able to do their work.
We do have some GPU-based systems, and that's for our visualization, our data analytics side. And we'll continue to do that. I think we'll also continue to look at where do GPUs fit best, what applications are best suited to them, what applications are best suited to a system like BlueJean. It's always a trade-off for an application and a scientific programmer.
Of course, we have GPUs in other parts of our product line, like the iDataplex, which supports GPUs. You know, we don't believe that one size fits all. The clients have various needs within their applications and their codes. So we have a portfolio of products to be able to address each of those needs.
While the players may not be unanimous about what type of acceleration solution is the best way forward for the HPC market, one thing is clear. Whether it's DSPs, GPUs, or Intel's mic architecture, the increased need for speed means acceleration solutions aren't going away anytime soon. This is Sylvie Barak at Supercomputing 11 in Seattle for EE Times.